In the hunt for an evil twin to our sun that shakes comets loose and rains death across the Earth, all of the pieces are in place, except one.
The Nemesis theory really needs the smoking gun of actually finding direct evidence for the object itself in order for the whole thing to hold together.
Now, why haven't we found it yet? Actually, there are quite a few astronomers who don't pay very much attention to this and simply assume that if it existed, it would have been found by now. We believe this thing can be found within the next few years. What it takes is a survey of dim stars.
Enter WISE, the orbiting wide-field infrared survey explorer. A powerful new tool that just might crack the Nemesis mystery.
The reason that WISE is going to be so good is because it operates in the infrared. It sees heat, basically.
By measuring heat instead of light, infrared scanners can make warm but dark objects easy to spot.
The nice thing about looking in the infrared at the heat of it is you don't care how far away you are from the sun.
Jupiter provides an example. The temperature on the surface of Jupiter measures 230 degrees below 0 Fahrenheit. But that's blazing hot when contrasted with the 450 degree below zero temperature of space. So even in the absence of sunlight, a distant Jupiter-like planet would glow brightly in the infrared. By visiting a motor speedway, we can see how the WISE survey might help find Nemesis by exploiting the infrared contrast between objects of different temperatures. Here, the roar of the engine only tells half the story.
I came out here today to the Drive Tech Racing School to be in a race car that would go zooming around this track a bunch of times. And the idea was to film the car with an infrared camera and show us things that are hot, hotter than the outside surroundings, and glowing at infrared wavelengths. So hey, Ted.
How you doing?
Good to meet you.
Likewise.
Yeah, you're the driver?
Sir.
Now, how fast are we going to be going?
Approximately 170 miles an hour.
Now, that's about 3 times normal highway driving speed,
Yes,
so
sir.
whoa, things are really going to heat up.
Oh, yeah.
All right, let's go then. Blair Dupree of Drive Tech helped me get into the car.
This is a nice thick helmet, huh?
And it's not so easy because there's no doors, okay? You have to kind of climb in through a window.
Bring your left foot up in there.
Okay.
Bring your right foot on up.
I feel like I'm breaking into a car. And then kind of slither your way in. Being in that race car was really exciting. When I was going around the turns, I could really feel the G-forces.
Ted, give you a good ride, didn't
Yeah, well, I'm glad Ted was the driver. I couldn't do this, you know? I was scared out of my seat and I wasn't even the driver, okay?
With the car nicely warmed, a FLIR infrared camera, set up by thermal imaging expert Ross Overstreet, sees everything literally in a new light.
Hello, Allie. Hey, Ross. How are you doing?
Doing good. How are you doing?
Good, good. Let's look at these infrared images.
Right now we're pointed at the back of the car. The best way to think about it is it's more of a measurement device than a camera. It's like having a million different thermometers spread across the image. We're actually getting temperature measurements on each of those pixels. Things that are supposed to be hot look like they're glowing. They're red and orange and white. And things that are cold are colored blue and black, and colors you associate with cool objects.
Right.
And you'll notice there's several different hot areas of the vehicle.
Now, I see some variations across the tires.
Yeah, and you'll notice that the one tire is a little bit warmer than the other.
The right-hand tire was indeed hotter than the left-hand tire because there was more pressure on it during the turns. So how hot is that hotter tire there?
We made a measurement earlier of about 190 degrees Fahrenheit, almost the
Right.
temperature of boiling water on the tires.
When we just look by eye, we can't tell whether something is hotter than something else, but here you can tell, and that's really cool.
Right, this camera would work just as well if it was pitch black or in the middle of the day. It doesn't care about solar light at all.
The infrared camera sees the racetrack the way the WISE survey scans the dark and faraway realms of our solar system. If Nemesis is out there, infrared should reveal it.
The hot spots of the race car are sort of like warm, glowing objects out in the cold depths of space, far from the sun. This is a whole new way of discovering objects. Objects too faint to be seen through a normal optical telescope, but bright enough to be detected in the infrared.
The WISE telescope completed its sky survey in early 2011. But in the search for Nemesis, the results are still inconclusive.
The WISE survey is going to take a long time to analyze, simply because there's a huge amount of data that had been gathered by this craft.
About half of the Nemesis candidates have not yet been studied, but in the next few years, we expect the theory will be either proven right or wrong. Until that time, it is and should be controversial.